Welcome to this video where I will go through the IRENA FlexTool tutorial. The instructions can be found from GitHub. Maybe you already have them open, or maybe you're doing this together with me, however you want. So I have my Spine toolbox open here, and first let's start by opening the FlexTool. So I do it from File, Open Project, and then I find the FlexTool that has the little spine icon next to it. And here we have it. This is the workflow, and all the data will be added here in the input data. And you want to make sure this should be fine, but I'm just gonna say it at this point that if you for this tutorial, and if you have installed this according to the instructions, you would have something, the file here would be called something like input data SQLite. Or if you later wanted to open another file, you could change it here, or I mean the database for the input data. But this is what we want at this point. So let's open the editor by double-clicking the input data icon from the workflow. And now this is where the data will be added. And we're gonna create this model by using alternatives. So this is actually, I just did this already, but we can remove it and do it again. So let's go to I'm on the right, the alternative tree, and let's call the first alternative West. And later on, when we want to create the actual scenarios, we then choose what alternatives we want to be included in each scenario to run the model. But let's go back to that later. So at this point, let's start by adding a node. So here on the left, we have the object tree, and I want to go to the node icon and right click and then add objects. And I'm going to call the first object West, same as for the alternative. Wouldn't have to be this way, but that's for the tutorial purposes. And then once we have added the node, we can then find it from all the nodes available. So right now we only have West, and then we can add the parameter values. So for this node, we will need some parameters for this to make any sense at all. This is a very simple model at this point, but still, let's add the most critical ones. So let's start by inflow. And now everything that we add as all the parameters we add, we have to choose which alternative it's for. And at this point, we want everything to go under West. Now, this inflow, we want it to be the demand for this one specific node. So the node West, it could be like the region, the western region of our, I don't know, city or the network that we're modeling. So we want this to indicate the demand that this West has. So thus the inflow must be a negative value. And this could be a constant value here, like minus 400 megawatts, but that's not really what we want for the demand to be constant, right? Or we could, but it's not the best option. So instead, we want something that's called, I click this, I right click this and click the edit. So we want something that is map type parameter. And this is where we can define the inflow or in our case, the demand for each hour. So if we wanted this to be for a full year, we would have 8,760 time step if we wanted each time step to be 1 hour. And it wouldn't have to be defined this way, but this is just how I think it makes a lot of sense. But since I don't want to do this by hand and I don't really have any data ready, I'm going to cheat a little bit. I'm going to open the workflow again, and then there's the init database as well. This has some data that we can use for this demo purpose. So let's find the West node. Oh no, this is not the right one. Hold on. Oh, I had a minor setback as my init database was not the right file, but now I changed it and it should be, you should also have it called init.sqlite, and you can change it the same way I showed you in the beginning, but it should be fine if this is the first time you're running the model. Should include this file. So what I wanted to do is to find the West node, find its inflow, and here they have the map type parameter. And I'm just going to copy these values. So I choose all of them and then Control-C, go back to my input database where I have the inflow for the West node, and then choose the map from the list and then Control-V, paste the values here. Now, ta-da! Okay, let's go forward. So what else? What are the other parameters that we need for our object node called West? So we need something that's called has balance. And this indicates that this node has to maintain energy balance at all hours. It only has one option for the value, and that's called yes. And then also another yes value is needed for is active parameters. Let's choose it from the list. Goes under West and yes. And this indicates that this West node will be sent to the model. It's just the way that this is built. This has to be done for each node and unit we are adding. And then as our, because we don't have any units yet, but we have said that the model has to maintain energy balance regarding node West. How would the model do it if there's no energy, or like there's like, this doesn't really make sense at this point, right? So we're not gonna add any units yet, but instead we are adding something that's called penalty. Penalty values, we're gonna add penalty up and penalty down. And now this means that we put a cost of 9,000, be it euros or dollars, I'm not sure. 9,000, and this means that whenever the model doesn't generate enough energy, and at this point, this is never, the model will produce megawatt hours out of nothing at the price of 9,000 euros per megawatt hour. Hope that makes some sense. So I'm gonna give a little spoiler that the model, when we run the model and we look at the prices, it should only, like, each hour should have the price of 9,000. because it has to use the penalty, has to pay the penalty because it doesn't maintain the energy balance. That makes sense. Okay. Then this is all that we need at this point for the node west. So now I want to save the work, and I'm going to do it by pressing Control Enter, or actually this is the shortcut, but I will show you. I'm now on the upper right corner, and there's this, where are you? Here. Under the session, there's called this little tab, and it's called Commits, and the shortcut is Control Enter. So here, this is kind of like saving the work, and always I cannot commit before I write a message. And this is maybe useful if you're building the model together with someone, or just to remind yourself later in the process that what did you do at each step. So I'm just going to write here, node west added, and commit. And now the little asterisk disappeared from the data tab. So now I go back to the workflow. No, actually I don't, not yet. We cannot run the model yet. We still are missing some very important parameters that define the model structure for time-related issues. At this point, this might feel a bit abstract, but I encourage you to just bear with me and do the steps as the instructions show, and maybe later when you keep doing this, you can explore the different options and fully understand what's going on. But this is very abstract at this point. But we need to do this to make sure that the model runs. So first, let's again start by defining a new alternative. And let's call this alternative init. And all the structure related abstract model stuff will go under this alternative. So let's start by adding a timeline object. So let's find it from the object tree on the left and add object timeline, and let's call it year 2020 or Y 2020. And for the parameters, let's choose this time step duration, which defines the time series that the model will use under init. And this is, we want to put it in as a map value. So, or parameter type called map. So in the first column, we need the name of each time step. And then in the second column, the length of each time step in hours, the length of each time step in hours. So, and the time step names need to match the previously given inflow time series. So we need the T001 to T8760 to have all the time steps, and the length of each time step is 1, as in 1 hour, right? Since we had the full year. So let's again go and copy these values from the init database. So let's find the timeline, and it has the map, and let's copy these values. these values can also be copied from like Excel, but I will just copy them from here and Control V to paste them, okay? Okay, next we need to add something called time block set. So let's add this and, oops, not the group one, but the regular one, add time block set object. And let's call this today. So this one defines what is the start and the duration of our model. So since we just called this today, let today, or like 2 days, we want it to be a 2-day model, so 48 hours. So that's why for the block duration, we want to add it as a map again, but we want it, so the first column here, it defines the starting point. So we want to start from the beginning, so from the first hour. And then the second column is what is the duration, like from these hours, how many hours forward. So this is 48 hours for us since this needs to be 2 days. So if we wanted to do a longer run or like longer time period for this run, we would define like for a full year, this would be 8,760 hours. But for us, we want it to be 2 days. Then these two that we just added, so the time block set and timeline, they need to have something that's called relationship. And relationships are added below the object tree. There's something called relationship tree. So now let's find the time block set timeline relationship and add relationship and then connect these two to each other. Then next we need something that's called solve, again from the object tree. Let's find the solve and add object. And let's call this one year 2020, 2-day, and dispatch. And then for this, let's add the parameter called period time block set, which defines the time block set that we use for each period. So for this one, I have to cheat. Yes, it's a map again. Let's choose the map from the list. And then we need, for the first column, we need the period, which in our case is P2020. And then the second column is called the 2-day. Yes. Then next, something for the same solve object, we need something that's called realized periods. And now this is not a map, but it's actually an array. So for the, and I can, for this, I can actually define, you don't have to do this, but just to show you more clear that the first column here should be the period, which we defined to be oops, we have the value type here as float, but we want it to be string because we want this to be period 1. And then the second one to be the period that will be realized in the result. And that's the only period we have, but if we have had more periods, then we could list them here. Now I'm gonna cheat again. Is that everything? Then finally, one last parameter for this solve object is something called solve mode. And this one we want to be dispatch single. We could also do an invest solve, but that's not what we're gonna do now. Then finally, an object called model should be added. Where are you? There. Add object, and let's call this model FlexTool, right? And then this one should have the parameter solves, and it also has to be an array. With string, and this should be what we defined earlier. So Y2022 day dispatch. Okay. Now I want to see what all is under my inits and make sure that it matches the tutorial instructions. So there's the model, there's the solve, then timeline, time block set. And these should be fine. Okay. Now let's commit by Control Enter. Init added. Okay. And now, even though this is a very simple model at this stage, and it doesn't do anything interesting, I mean, we don't have any generation yet, we don't have any units yet, it can actually still be executed. To do that, we need to create a scenario. Let's call this scenario base. And once we have named it, we can choose the alternatives to be included in the base scenario. So let's choose the two that we have at this moment. So West and init. And then I actually have to commit again. So every time there's an asterisk here next to the input data, that means that the work is not committed. And if I now ran the FlexTool, these changes that have not been committed yet, they wouldn't be included in it. So first scenario. Okay, then let's go back to the workflow window. And we want to run not the whole thing, but just these three: export to CSV, FlexTool 3, and then import results. To select all these three, I'm gonna press Ctrl and click these three, and then execute the selection. So the middle one here, not the whole project, but the selection. Okay. So the export CSV, that makes the files suitable for the FlexTool to understand them. Then the FlexTool calls the model for each solve. And finally, the import results will take the output files from FlexTool to the results database here. And then we can explore the results from the results database. And now, since everything went well, the execution was completed, this green tick here means that it was successful. So now let's double click the results and let's explore them. I have actually all my previous runs here. Let's see. I should have maybe deleted some of these before. Let's try this again. Close the window. Okay. I actually don't want to show you all of these. Let's just look at this one. Great. So let's look, for instance, the price map. We can see the values by clicking this edit again. And this is how it should look. It has our 48 hours, great, but the price for the energy at each hour is 9,000, which maybe you remember is because that's the penalty value, because we're not meeting the demand. So we have to pay the penalty value each hour. Okay, so not very interesting at this point, but it works. Great. Now, let's go back to the input data. And let's continue. So let's add our first unit. And let's start by adding a coal unit. So first, let's create a new alternative again. And let's call this coal. And now everything we want to add to the coal alternative. So we need first 3 new objects. We need unit, node, and commodity. Let's start with the unit. Add object. Let's just call it a coal plant. Of course, if we had multiple coal plants, they should be called like coal plant, or maybe it's just the name of the coal plant, not just the general coal plants, obviously. And then let's add the parameters for this one. So let's choose the coal. We need something that we used earlier as well, and that's called isActive, which means that the model will recognize this unit. But now let's get to the more interesting stuff. So first, the existing means the existing capacity of this coal plant in megawatts. So we can put like 500 megawatts. That's how big our coal plant is. Then, of course, we need the efficiency. Obviously, it's not 100%. And even if it was, we would need to define it here. Let's put 40%, so 0.4. Then, is that all for the unit? I think so. The next, let's add the commodity coal here, so that the coal has to have price, of course, and that this is where we define it. So price, and let's put 20 euros per megawatt hours of fuel. Then we need a new node called coal market. So this is where the commodity coal will be sold, where it can be bought. And for this one, we just need the isActive parameter. But what we now need to do is that we need to add the relationships. So that's again from the relationship tree. Let's find unit input node here, add relationship, and then we have the coal plant unit, and input means that it takes its input from the coal market. So that means that the coal is coming, the plant gets its coal from the market, and it pays the price from the market. And then we need the unit's output node. So where is the coal plant then producing the electricity to? And that will be west. It will be producing to the west node, where we have the demand. Okay, and then one final relationship at this point is the commodity node. So commodity coal goes to coal markets. So now all these parameters for the units have been connected to each other. Let's see. Yes, now it should be, everything should be in place. Let's see, coal plants added. Let's create a new scenario called coal. And let's choose all of these existing alternatives to go in there. And now, second scenario. And now let's run the model again. Let's see if we get the production from the coal plant. So let's select these same ones, 3 of them, and execute selection. And we wait for a little while. All right, let's double click the results. Nope, let's wait. Now, okay. And again, don't mind my too many runs here. I just want to see this one. So now let's see if we have some changes in the price results. Great. Now there's still some hours when we don't meet the demand, so that's when we have to pay the penalty value. But in other hours, we're paying 50, meaning, I mean, this one comes from the price of coal. So that's great. Let's see if there's something. Is there something interesting? Probably not yet at this point. So let's go back to the input data. And actually, I wanted to show you something real quick. We have the table view, but we could also have the graph view. If we select the whole route, we can now see that this is our west node where we have the demand, and it's coming from the coal plant, which gets the coal from the coal market. So at this point, as we can see, this is very simple, but maybe when we get more complex system, this is something that can help us to figure big picture, and also to make sure that the right things are connected to each other. But let's go back to the table view. And next, let's add a wind plant. So let's create a new alternative called wind. And let's start by adding objects. Unit, wind plant. And then the other object that we need is called something, it's called a profile. And let's call this the wind profile. And before we add these parameters, let's actually add the relationship. So, well, because wind is, it's renewable energy comes from the wind. So obviously it's not a commodity like coal that we can buy from the market, but of course there needs to be something that defines how much wind we're getting, or like what is the kind of the output for the wind, input for the wind plants. So the model gets it from the profile, which we will add later, but it's basically a capacity factor for each hour. I mean, an hourly capacity factor for the wind plants, so that it depends on how windy it is. Yeah. So, but first let's add some relationships. So first we need unit node profile. Units node profile. And maybe you already guessed, but the unit is wind plant. The node is west, because it's the it will be, it belongs to the west node, so the west region. Then the profile is wind profile, and then another relationship is called units output node. There. Add relationship, unit, wind plant, and it is for the west node. Okay. Then let's go back to the wind plant and let's choose the parameters. So we need, well, let's start from the easy one. We need the is active. Yes. And then we need existing, the same thing we used for our coal plants. And let's set this to 100 megawatts. Then we need efficiency, just like we did for the coal plant. But in this case, let's put it to 1. And then something different is the conversion method, which is the method for the conversion process. And here we can use, instead of a load curve, we can just use the constant efficiency. Then for the wind profile, let's add a parameter called profile. And now this is what I was talking about earlier. So this is the capacity factor for each hour. And maybe you guessed, it's a map. And I'm gonna cheat again. And I'm gonna copy the map from our init database. No. Profile. Wind profile map. And let's copy all these values. Control C. Edit. Map. Control V. Okay. Then one more thing. We need some parameters for this relationship. So let's go to the units node profile here, and no, where is the one we already have? Okay, we need the profile method. This indicates that, well, when we choose from the list the upper limit, this indicates that the wind plant must generate at or below its capacity factor, the capacity factor that was defined in the map for the wind profile. Now let's create a new scenario called wind. And let's commit. And then execute. And let's see what changes. So let's select these three again and execute selection. Wait, I think, let's see, did I forget? I forgot. Our wind doesn't have any alternatives. I just created the scenario but forgot to include the scenarios. We can stop the execution and let's go to make the scenario include the actual data or the alternatives. And now okay, and now let's try this again. Go back to the workflow, select these three, and execute selection. All right, let's explore the results. Give it a little time to process, apparently. All right, double click the results and choose. All right, now let's see what the prices look like for the West node. So there's less penalty values because now the wind plants also helps to meet the demand. Let's see. Let's make sure that there's, yes, the wind plant has the capacity. And is there something else that we can look? Let's look at this one. This is the inflow. And then it here it indicates how much we get from the units. And as I remember from the price map that we just checked, the first hour we had to pay the penalty value because we didn't meet the demand. But as we can see from here that we almost met the demand, was just like 50 megawatts or something. That was 55 that was missing. So that's great. But next we're gonna add some network and some connections that may help us. I just realized that since already we cannot meet the demand, and in this tutorial we will only be adding the demand, not the generation. Of course, we could add units, but let's stick to the instructions. And to meet the existing demand and the demand that we will be adding in the next step, I noticed that the wind plant capacity should be 1000 and not 100 as I put it. So I'm gonna edit this. And now if we run it again, start committing. Now if we run this one again, we should not see any more penalty values, but instead the larger wind capacities should help us to meet the demand at all hours. So let's see if that's how it goes. Let's try that again. So now if we look at the newest results and look at the price map. Great, there's no more penalty values here, but instead there's this is price for the coal when we need the coal plants. And this is when the wind plant alone can meet the demand. So the wind is free as of the fuel, kind of. This is not taking into account the investment. Okay, but great. Now let's move on to the final step. As I said before, we will be adding more demand, meaning we will add 2 more nodes. In addition to our west node, we will have east node and north node, which have their own demands, and then these 3 nodes will be connected to each other. So in this tutorial, our 2 new nodes, they don't have any units, but instead they get their electricity from the units that are at this point only in the west node. So let's create alternative called network. Then, like I said, let's add 2 new nodes. node east and node north. Okay. Then 3 new connections. The first one, we will call it east, north. Second one, west, east. And third one, west, north. And then let's add the parameters. So first, for the nodes east and north, we will add the is active and has balance. Let's start with the easy ones. Then, like we did for our first node, the west one, we need the inflow, which as a negative value indicates the demand. But now let's not mix it up with the map, but for this simple tutorial, let's just have it as a constant value of -300. And then let's also add the penalty values. So penalty up and penalty down. There. And the penalty down. Okay, and then the same parameters for our north node. So is active, has balance, and for the inflow, let's also just use a constant value of 200 and penalty up 3,000. And 2,000. Great. Now, for the connections, we need some parameters as well. So again, we need the is active to make sure the model sees them as active members. Then we need the existing, meaning the capacity of the network or the connection line. And for this one, we can put 200. This is in megawatts. And then also the efficiency indicating the losses in the network or the connection lines. Let's put 0.8 efficiency. And then same for all of our connections. Is active. Existing. And efficiency. And for the third one, let's put 100. And 0.9 efficiency. Okay. Now, since our north node here, this one has the lowest penalty values, or the upward penalty, compared to the other two nodes. This means that whenever our wind and coal units, so the only units we have at this point, are not able to meet the demand, the model will prefer to use this north node to make sure that the costs are as low as possible. Yes, but actually before we can run this, we also need some relationships. So at this point, our model, like, we have these connections, but these are just names, right? So model doesn't actually know that the east node and north node are connected, because this is just the name. So that's why we need the relationship. So we add it from the connection node. This is very simple. We choose the connection and then match the names of the connection name. West and north. Okay. And now I'm gonna check that I have everything here. I believe I do. Except for the scenario. Actually, I just realized that these scenarios should have been named like network wind coal, because they have all of these together. But that's not a problem. Okay. Now commit network. Now let's run. But since all of our generators are producing the energy or the electricity to our west node, there will be now times when the connections that we just did between the nodes, they are not sufficient to carry all the power we need. So let's see how this impacts our results. Okay. Now we have a bit of a different kind of values here. Good look at all of these together by plotting them. This shows the price at each hour per different node. So these are the hours that the wind power is able to meet all the demand, like from all three nodes. But the other values are sums of the penalty values or and the coal. Yes. So feel free to explore more. I think this is now everything that I have to show you. Here we have the commodity upward. Yes. And actually I still wanted to show you the graph of our final. Let's choose the whole root. I think this is fascinating. So there's our all of our nodes, the north, east, and west, which actually aren't really in the west and east and north, quite the opposite, but let's not think about that. But we have the coal plant and the wind plants producing to the west node. And then we have connections to both east and north, and also there's connection between east and north. The coal plants works or generates according to the coal market, so basically just buys the coal from the coal market for the price, and the wind plant generates energy according to the wind profile. Yes. So that's all from my side. Thank you for watching. I hope you found this helpful. And yes.